Here we're going to solve the equation 4 parenthesis x plus 1 to the 1/2 power minus 5 parenthesis x plus 1 to the 3/2 power plus parenthesis x plus 1 to the 5/2 power equals 0. Well, this is a very strange looking problem, and at first I would be panicked about what to do until I recognize that there's something consistent here. I just think about it, I go, let w equal the x plus 1 to the 1/2 power. Now, why did I choose that? Because look what happens. From that we can get 4w minus 5w squared plus w to the 5th equals 0 by making that particular substitution in the given equation. Now, I know it's hard to see, but think about it. If w equals the parenthesis to the 1/2 power, then 4 times w is the first term, 4 parenthesis x plus 1 to the 1/2 power, and minus 5 cubed, well, that's minus 5 times w to the 1/2 power to the 3rd power. So you multiply the exponents together and get the 3/2 power. And similar action for the last term before the equal sign. If it's x plus 1 to the 1/2 power, if you raise that to the 5th, you get the 5/2 power. So yes, indeed, that is an appropriate w substitution. So now we can proceed with our method of factoring to solve this equation. We're going to factor the non-zero side because this is a polynomial equation. It's a higher than first degree equation in w. So first thing I notice is we have a common factor of w on all three terms on the left side. So pull out that common factor of w. We'll get w times 4 minus 5w squared plus w to the 4th. W to the 4th, parenthesis equals 0. You can check that to make sure it's good. Okay, set each of your factors equal to 0. You get w equals 0, and then the big parenthesis is 4 minus 5w squared plus w to the 4th. I just rearranged it as w to the 4th minus 5w squared plus 4 equals 0. Okay, so I've got the w equals 0. Let's convert back to x plus 1 to the 1/2 power, because that is what w is. It's x plus 1 to the 1/2 power. That is equal to 0, according to our w equals 0 result. And if we solve that, we're going to raise both sides to the 2nd power to get rid of the 1/2 power. We'll get x plus 1 to the 2/2 power. In other words, it's x plus 1 equals 0 to any power is 0. And then move the 1 to the other side. We get x equals -1. Now let's work with the other factor. W to the 4th minus 5w squared plus 4 equals 0. We're going to do another substitution here. If we let v equal the middle variable w to the 2nd power, okay, then v is going to be v to the 2nd power, I should say. Then v to the 2nd power is going to be equal to w squared to the 2nd power, which is w to the 4th. In other words, when we make that substitution, we get v squared minus 5v plus 4 equals 0. Now factor by guessing. V minus 4 times v minus 1, that'll work, equals 0. Set each of their little factors equal to 0. We're unioning all these solutions together, by the way, with the union symbol. We get v equals 4, union together with v equals 1. Now go back to what v is equal to. V was equal to w squared. Okay, so we've got w squared equals 4 and 1. Now, go back to the original variable. The value for w is x plus 1 to the 1/2, and we're going to square that equals 4, and x plus 1 to the 1/2 squared equals 1. That gives us, when we, let's see, we're going to just simplify. We get x plus 1 equals 4, x plus 1 equals 1. Isolate the x, we get x equals 3, union together with x equals 0. So we got 3 solutions for this problem. The solutions are in set notation, -1, 3, and 0. Those are the values for x that satisfy this equation. And you can check each of them to make sure they're valid. I kept them because they are valid, but you really need to check to make sure. Very nice problem. Required 2 iterations of substitution. So it got kind of complicated, but you just don't give up. You just continue until you've isolated all of the x values.